Okay, firstly in our control circuit we have the TF494 IC, which will be used to produce a 3-volt peak sawtooth waveform. Now we're going to use this trimmer located here along with this capacitor to produce this 3-volt peak sawtooth waveform. Nextly we have the LF356 op amp in a non-inverting configuration in combination with this trimmer located next to it to produce a 10-volt peak sawtooth waveform. Nextly we have the LM311, which will use the control voltage from this trimmer and compare it with our 10-volt peak sawtooth waveform in order to produce a PWM signal of a certain duty ratio. The PWM signal then goes into the CD4050 located here, which is used in combination with the MIC4424 located here to increase our drive current. Finally, we have our isolated driving circuit, a pulse transformer in combination with some passive components, which is used to provide some isolation between our control circuit and our converter.
是我们的 Flyback converter 的实作电路图。我们这边借由输入110 AC， 经过桥式整流变成156 DC。这边是我们的 RCD snubber， 这边是我们的 RC snubber， 这边是我们的变压器，这边是 N1 比 N2 是7:1。这边是我们开关，借由驱动讯号、驱动电路传送驱动讯号给开关的 GS 角。这边是我们的输出是12伏，然后我们满载是24瓦，然后12瓦以上的时候 CCM。这边是我们这一条是我们的测量 IDS， 这边是 ID。
Here we have our probes placed for the measurement of V-in, V-out, and VGS. We're expecting 156 volts DC on the input here, and we're expecting a 12-volt output over here. Firstly, we could see our VGS waveform right here. Next, we have our input of 156 volts, as we can see by the measurement number 4 right here. And last but not least, we have our 12-volt output right here. Here we have our probes configured for the measurement of the voltage across the gate and the source of the MOSFET, as well as the drain and the source of our MOSFET. Here we can see the VGS waveform as previously seen, as well as our VDS waveform. The spike expected as well as the ringing across the waveform have both been dealt with using our RCD and RC snubbers. Here we have our circuit configured for the measurement of IDS. Since we are unable to measure the theoretical magnetization inductance, we will use IDS as an indication as to whether we are in CCM or not. As seen right here, since the initial current during the on state is not 0, we are indeed in CCM. We can see again that our initial value in the on state is non-zero, meaning that again at 12 watts we are still in CCM. As can be seen above, we are starting with an initial current of 0 amps, which means that we are operating in DCM when we operate with an output load of 11 watts. The green plot is the output current and the purple is the output voltage. You can see at this point in time the current goes from high to low, indicating that we're moving from a high load here to a low load down here. We can see up here that there's a very slight variation, a slight increase in the output voltage as we move from a heavy load to a light load. We can see in the reverse situation, moving from a light load to a heavy load, as the current increases at this point in time, there is a slight drop in the output voltage as seen here.